Hey guys, this is Dr. Looney back with another video. This is just a second fundamental theorem of calculus continued. So we're going to go ahead and get right into that. I just wanted to show you just a few problems that you could look at and just to see how this could possibly be questioned on the AP exam. So we're going to start off what I would say would just be a low-level problem. So let's look at this one right here. We have f of x is equal to the integration from 1 to x cubed, and we have 1 over 1 plus the natural log of t dt, and they want us to find f prime of 2. And so we're going to use the second fundamental theorem of calculus to do this particular problem. So let's go ahead and look at that. So when it says find f prime of 2, so that means we're going to have to take the derivative. So let's go ahead and look at that derivative. Remember, the derivative cancels. When we take the derivative, we can get rid of the integration sign. And now everywhere we see a t, we're going to put the function x cubed. So we get 1 plus the natural log of x cubed. And so you see now we're taking the derivative of x cubed, which is just going to be 3x squared. And then the next thing that we simply have to do is now, since we want to find f prime of 2, everywhere we see an x, just put a 2. So let's do it. So here we have 1. So we don't have to change anything here, but everywhere we see x, we're going to put a 2. So we get 2 cubed, and then we get 2 squared. And so now we're going to get 12 over 1 plus the natural log of 8, and we're done. So again, you can pause this video anytime you would like and go back and review that. But I think that problem was pretty straightforward. And I kind of really wanted to give you some more practice with the second fundamental theorem of calculus. So let's move on to the next type of problem that you could possibly see. Now this one is asking us to find the minimum. So it says, at what value of x is f of x a minimum? And so in this particular case, when we're trying to find minimums, that's where we find critical values. We set the function derivative equal to 0 and find the x, and then we test the point to the left and the right. And I don't know if you remember that, but so this is kind of combining two concepts. We're using the second fundamental theorem of calculus, or we will be using the second fundamental theorem of calculus to do this, and the ideal of finding relative max and min. So let's go ahead and do that. We can see here we're going to have to take the derivative of f of x, which is written as a function. And so generally when you're taking the derivative of integral, then you're going to be using the second fundamental theorem of calculus. So let's look here. Let's go ahead and find f prime. So f prime, again, since we're taking the derivative of the integration, we get rid of the integration. Everywhere I see a t, I'm going to put my upper limit, which is this function 2x squared minus 4. So now this just becomes e to the 2x squared minus 4, and I always multiply the by the derivative of the upper function. So that now becomes 4x minus 4. Since I'm looking for a critical value, I can see that these functions are always defined. So the only place I'm going to be looking at is when it's equal to 0, because a critical value can be at wherever the first derivative is undefined, or if it's equal to 0. So that's what we're going to be looking at here. So let's go ahead and look at that particular function. So one thing to note, if you take e and you raise that to any function, that's always greater than 0. So the only part of this particular derivative that could be equal to 0 is the 4x minus 4. So I'm just going to set 4x minus 4 is equal to 0. So that implies my x is equal to positive 1. And so I know that doesn't really look like a 1. I apologize, but this is x is equal to 1. So that's my critical value. Now I just need to test points to the left and the right of that. So I am going to use 0 to the left, and I'm going to use, let's just say 2 to the right. So remember, we're trying to see what the derivative is changing. So in this particular case, if I plug 0 into the derivative function here, well, this we've already discovered is always positive, so we don't have to even think about this. Just remember, it's always positive. And if I plug 0 into here, I get negative 4. So a positive times a negative is just going to be negative. So I know to the left of 1, I'm going to have a negative value for my derivative. And then I'm going to use 2 for the number to the right. Again, this part, e to the 2x squared minus 4 is always positive, so I don't have to worry about that. So I'm just going to plug 2 into here, and so I'm going to get a positive 4, so I know this is going to be positive. So I can see that my derivative changed from negative to positive, so that means I did what? I decrease, then I increase, so at 1, I have a minimum. So that's going to be the answer to the question. What is the x value? The x value is equal to 1. So again, my x is equal to 1. That answers the question. Now this could get a little bit more involved because they could also ask you on what interval is the function increasing. So on what interval is f of x increasing? Well, f of x will be increasing where? Well, f of x is going to be increasing. I'm just going to do increasing. And I'm going to do this little arrow for increasing on 1 to positive infinity, right? Because that's where my derivative is going to be positive, and this is because f prime is greater than 0. So, and they could ask you when is the f decreasing, right? And you were right, you know, the justification for that. All right, and lastly, let's look at this problem. This one is a little bit more detailed, but we'll be using the first and second fundamental theorem of calculus on this particular problem. So we have g of x is equal to the integral from 0 to 1/2 x f of t dt. And this question is going to ask us to find g of 4 and g prime of 2. So let's go ahead and look at g of 4. Well, g of 4 is just, we're going to have to just plug in 4 everywhere we see an x. So g of 4 is going to be equal to the integration of 0 to 1/2 times 4 f of t dt. And so in this particular case, we know half of 4 is 2. So we're really just trying to find the area under the curve from 0 to 2. So that's just going to be this triangle right here, right? So that's just this area right here of this triangle. And so we can see that that's just going to be 1/2 the height times the base. So we get half of 4, which is 2 times 2, so that gives us 4. So g of 4 is just going to be equal to 4. And then lastly, we want to find g prime of 2. And now, since we're finding g prime of 2, we're going to have to find the derivative of this function, right? So in order to find the derivative of this function, since it is an integral, since this function is defined by an integral, then we're going to have to use the second fundamental theorem of calculus. So that means everywhere we see a f, we're going to first get rid of the integration sign, and everywhere we see a t, not an f, I'm going to put 1/2 x squared, then I'll be taking the derivative of 1/2 x. Okay, so I know I said 1/2 x squared, but I mean to say everywhere I see a t, I'm going to put 1/2 x. And so I'll be taking the derivative of 1/2 x. So let's look here. Everywhere I saw a t, I put 1/2 x, and the derivative of 1/2 x is just going to be 1/2. And so I'm trying to find g prime of 2. So everywhere I see an x, I am going to put a 2. So now I am going to get 1/2 times f of 1, because half of 2 is 1. And so now we need to determine what f of 1 is. So what is f of 1? Now, in order to determine what f of 1 is, I am going to have to look at the graph. So in looking at this graph, this is the graph of f, and I want to find what f of 1 is. And so that's somewhere in here, right? That's some point right here. Let's just say we want to find out what that value is going to be. Well, we can use the slope of this line to determine what that value is, because I can see that the slope of this line is going to mean that I'm going to have to go down 2 and to the right 1. So that means the slope of this line is going to be equal to -2, because -4 divided by 2 is just -2. And I can rewrite that as -2 over 1. So that means when I go down 2 and over 1, I should be at this point right here. So let's look to see what that y value is. So if I go down 2, I'm at 4. So if I go down 2 from 4, I should be at 2 and go over 1. So this y value should be 2. So f of 1 should be equal to 2. And so, as you see here, I have f of 1. That's going to be equal to 2. Then I'll take half of 2. So g prime of 2 is equal to 1. All right, guys, so that concludes the second fundamental theorem of calculus. Hopefully, you guys do have a clear understanding of the second fundamental theorem of calculus. Again, if you have any questions, you can always email me, come to the class, the Google Meets, and ask questions. Please stop the video, take notes, and you will have an assignment that will come along with this video, and that will be due on Thursday by midnight. Okay, guys, have a great day.